this is Lee Merrick. I am doing a lesson for University of St. Thomas Math 005. It's the first lesson, and I am recording this under Creative Commons license with attribution. So the very first thing we want to take a look at is fractions. I know everybody just loves fractions the most. And I want to just point out that a fraction is nothing more than a division problem. And I want to point out on the old-fashioned division symbol, right? We normally have the number that's being divided here, and we have the number that's doing the dividing here. All right? This is the same as though we're saying this goes here and this goes here. And it used to be that things like paper were very expensive to make, and so they didn't want to waste large bits of the paper or vellum, and so they wound up setting it up this way with this symbol so that you could you wouldn't wind up having a lot of space being wasted, or you wouldn't be able to, it wouldn't make it so you couldn't see what was going on. Anyway, so fractions are division problems. I know people kind of like, I'm not sure about the division either. That's okay. We're going to get used to doing some of this stuff, and it should make it easier to work with. So one of the things you should do is practice seeing what you can factor out of something, okay? If you have, say, let's start with something small. We'll start with a 10 over 25. Now, from my perspective, I know that if it ends in a 0 or a 5, it's divisible by 5. All right, so let's go ahead. I'm going to take this and I'm going to say 10 divided by 5 is going to give me 2. And what I do to one part, I have to do to the other, otherwise it stops being equal. So I've got 25 divided by 5, and that's going to give me a 5, right? Because 5 times 5 is 25. So this is my reduced form. I don't have anything more that I can factor out. There's 2 and a 5. Both of those are prime numbers. We'll get to what that is in a moment. And this is as far as we can go with this reducing. All right, let's try one that's a little harder. And yeah, let's go with 14 over 42. All right, so I've got 14 over 42. And I know right away that I have 2's that are hiding in here. I can divide both of these by a 2 because this is a multiple of 2 and this is a multiple of 2, right? If it ends in 0, 2, 4, 6, or 8, you have something that's divisible by 2. So I'm going to take my 14 and divide that by 2, and my 42 and divide that by 2. Now my 14 divided by 2 is going to give me a 7, and my 14 divided by 2 is going to give me a 7. 42 divided by 2 is going to give me a 21. Now, if I take a look at that, I have a 7 here, and I also have a 7 here because 3 times 7 is 21. So I'm going to do exactly the same thing I just did. I'm going to have 7 divided by 7. And here I'm going to have my 21 divided by 7. All right. And 7 divided by 7 is going to give me a 1. And 21 divided by 7 is going to give me a 3. Now that's as far as we can go. Both 1 and 3 are prime numbers. All right. And in this case, we needed to do 2 iterations. Now, if you had spotted that 42 is 3 times 14, that's fine too. You could have just as easily, and again, if you notice it, you're welcome to do it this way. But if you don't notice it, there's nothing wrong with going through a couple passes through it to make certain that you've actually reduce it completely. So here I've got my 14 divided by 42. If I had taken the 14 and divided by 14, and if I had my 42 and divided by 14, I'm going to again have that 1 over 3. And yes, you get there a little quicker, but it's the bigger the number that you're trying to divide by, I find people have a harder time doing that. And so we wind up having issues with that. Another way you could write this, instead of just saying dividing by, I could take my 14 and my 42, and I could say that those things are equal to 2 times 7, and here I'm going to have 2 times 3 times 7. All right, and in breaking it up like that, it makes it really easy for us to spot 7 over 7 is nothing more than a 1. A 2 over 2 is nothing more than a 1. So I can go in and cancel that and that, which leaves me a 1 over 3. All right. So in this case, we would wind up with, again, a 1 over 3, and that will go ahead and give us our solution as well. So whichever way makes more sense to you, if dividing the whole number by some factor makes more sense to you, go ahead and do it that way. If pulling it apart so that it's down to its factors and then canceling those makes more sense, then do that. I'm not at all married to any one particular method. As long as it's a method that gets you the correct answer every time, I'm good with it. All right. So for the moment, I'm going to stop here and we will resume in just a moment.